Hello, my dear students. Welcome to the class of 12th English Medium. The subject is Statistics, Part 2, Chapter 2, Random Variable and Discrete Probability Distribution, brought to you by Vitan Sir. In my previous tutorial, which was the first video for the second chapter of the second part, we understood what is a random variable, what is a discrete, and what is a continuous random variable. You can find the link at the top of your screen. Now, we know that the random variable can be classified as a discrete and a continuous random variable. So, in 11th standard, when we studied about the variables and we studied about the raw data, we usually classified that raw data as either a discrete or a continuous frequency distribution. Means the variable was classified from the raw data into a discrete or a continuous frequency distribution. Now the first chapter of the second part, that was the probability chapter, we studied. If you think properly, you will realize that what we studied was kind of a raw data with the perspective of a variable, because we did not classify our outcomes. We directly used those outcomes as they were and then try to calculate them for the sake of probability and all those calculations. So what if we classify that outcomes? What if we try to classify our random experiment? Similarly, the classification of random variable, that is the random experiment variable, creates the probability distributions. That means if we classify a normal variable, we get frequency distribution. But if we classify a random variable, we call it a probability distribution. And they are, of course, of the two types: discrete probability distribution and continuous probability distribution. What we are going to study in this chapter is discrete probability distribution, and in the next chapter, which is about the normal distribution, that is based on the continuous probability distribution. Discrete probability distribution. Now, before we actually start with the definition, because it's a very lengthy definition for this distribution, let's just take an example. I believe that if we take examples, it becomes very easy to understand the actual definition, and we can even relate it with the example, and that way we can remember it for a longer period of time. I am taking the same example of tossing three coins, that is total 8 outcomes are what we get, and my random variable will be the same as before, that is number of heads. So it is 3 2 2 2 1 1 1 and 0 heads. Now what I'm trying to do here is classify. First of all, I need to write down my variables here in this table. So the random variable, which is x, also known as xi. As you can see from the data, we have a variable 0, then 1, then 2 and 3. So these are the variables we have here. Then we have the outcomes. Okay. Random variable 0, how many times does it occur in our tossing of three coins? That means how many times do we get 0 heads? That would be one time. So the frequency, this is kind of a frequency for our variable x. So 0 occurs once. Then what about getting one head? How many times do we get a one head? If you see the data, it will seem that okay, that's 3 times. So the frequency for getting one is 3. Similarly, how many times do we get 2 heads? So the frequency for getting 2 is again 3, and for getting 3 heads the frequency is 1. That means the total outcomes we have, the total frequency we call it, is 8. But the frequency is a concept of a regular variable. What we calculate in a random variable is actually probabilities. That means what we will be doing here is calculating probability of happening of these random variables. Let's see. 0. Let's take 0. How many times does 0 occur? One time. What are the total number of outcomes? 8. What is the formula for probability? M upon N. favorable outcomes divided by total outcomes. So what is the probability of happening of 0? That would be 1 divided by 8. Similarly, what is the probability of happening of 1? So 1 occurs 3 times and the total outcomes are 8. So that would be 3 upon 8. Similarly, for 2, which occurs 3 times, it would be 3 upon 8. And for 3 heads, the probability will be 1 upon 8. So I have found the probability of each and every possible outcome, and when I just make a total of all this probability, I get 1. So now from this point you have to think about it, that for example U is a sample space of a random experiment, X is a set of random variables derived from this random experiment. For each and every random variable, we have a set of probabilities denoted as Pi, where you can see here that all the probabilities are positive. We never get a negative probability. We have already studied in the first chapter of probability that all the probabilities always lie between 0 to 1. The minimum value is 0, the maximum value is 1. That means the probability is never negative, it is always more than 0. And second thing, when I make a total of all the possible probabilities, I get 1. Okay, now these are some fundamental rules. Number one, that probability is always positive, and second thing, that when I make a total of all the probabilities, I always get 1. So remember these things. Based on this, let's see what is the definition. Now this is a bit long definition, so stay with me. Suppose x is a function from sample space to real uh, set is a random variable which assumes all the values of the subset x1 x2 up to xn of the real set. Further, suppose x assumes a value xi with the probability pxi, where pxi is greater than 0 and summation of pxi is 1. Then the set of real values x1 x2 up to xn and px1 px2 up to pxn is called the discrete probability distribution of a random variable x. I hope you guys got it better than just giving it directly, because I just explained an illustration based on this, and I think you guys might be able to relate some things of some portion of this definition with the example I just explained. You get the random variable x1 x2 up to xn, you get the probability for each random variable, but the probability should be such that it should be greater than 0 and its total should be 1. Then the set of x1 x2 xn and px1 px2 pxn is called a discrete probability distribution of a random variable x. And if I try to show it in a tabular form, then my table will be x and px, where x is x1 x2 dot 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 xi dot 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 xn, and the probability will be px1 px2 dot 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 pxi dot 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 pxn. And the fundamental rule which you need to remember is that pxi is always greater than 0 and summation of pxi, that is the total of all the probabilities, should be 1. Now this is a condition, these are the conditions for validating this distribution. That means you might be asked questions based on this, that this is the formula, this is the distribution, check whether it is discrete probability distribution or not, where you will be checking these two rules, whether all the probabilities are positive or not and whether the total is 1 or not. If even a single one of these conditions are not satisfied, then that is not a discrete probability distribution. I will explain that further in this video. Okay, to understand the definition still better, let's take another example with which you are very familiar, that is throwing of two dice and the sum on the face of both the dice as the random variable. Now that's going to be a bit longer than I expected, because the sum on the face of the dice is are 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so minimum total on the face of the dice are 2 and the maximum are 12. Now number of outcomes, I have already taught many times the method of putting the symbols, the lines on the die. So there is only one outcome with the total 2. Then it increases one by one, 2, 3, 4, 5, 6. The maximum 6 outcomes. Then again it decreases one by one up to getting to one outcome. And when you make a total, it becomes 36 outcomes. So now you need to calculate the probability for that. So total 36 outcomes are there, and for getting a total 2, the number of outcome is 1, so the probability will be 1 upon 36. Similarly, for getting total 3, the probability is 2 upon 36. 3, 4, 5, 6, 5, 4, 3, 2, 1 upon 36, and when you make a total, it is 36 upon 36, that will be 1. So both of our conditions are satisfied here. Number 1, all the probabilities are more than 0. Number 2, the total of all the probabilities is 1. So you need the set of xi's, the set of pxi's, the probability positive, and the total 1. These are the 4 main things which you need to check when creating a discrete probability distribution. Now to do the sums based on this, I am starting with the exercise 2.1, and I will do 2 sums from that exercise in this particular tutorial. Next time I will discuss some other concepts and do other sums of the same exercise. Exercise 2.1. Naturally, I am going to start with the first question. We have to examine whether the following distribution is a probability distribution or not of the discrete random variable x. Now the distribution is given as px is equal to x plus 2 upon 25. So this is kind of a function, and the values of x are already given 1, 2, 3, 4, 5. So what we need to do here, that take the values of x, each and every value of x, and one by one put it into the function of px given. How? When x is 1, the p1 will be 1 plus 2 upon 25, that would be 3 upon 25. Okay, so when I take x is equal to 1, the p1, that is pxi, will be 3 upon 25. This is the probability. Then I have to take x is equal to 2, so p2 will be 2 plus 2 upon 25, that would be 4 upon 25. Similarly, when I take x is equal to 3, it will be p3, that is 3 plus 2 upon 25, 5 upon 25. Similarly, when I take x is equal to 4, 6 upon 25. When I take x is equal to 5, that would be 7 upon 25. Now, we have to verify whether these answers belong to a probability distribution or not using our 2 fundamental rules I just told you guys. Number 1, are all the probabilities more than 0? That's the first question. Now just check all the answers. Is there anything negative there? No. So all the probabilities more than 0? Yes. Number 2, is the total of all probability 1? Okay, so for that we just need to take all the probabilities, which would be 25 upon 25, that is 1. So yes, the total of all the probability is 1, and so we can say that given distribution is the probability distribution of the discrete random variable x. So yes guys, this is how we solve a question of this particular kind, where value of x is given, the px function is given. We have to verify, take the value of x, put it in the function, check whether answer is positive, make a total of all the answers, and check whether it is exact one or not. If both the conditions are satisfied, then yes, it is a probability distribution. And if one or both of the conditions are not satisfied, then no, this is not a probability distribution of the discrete random variable x. Let's move on to the second question. Second question: if the following distribution is a probability distribution of the discrete random variable. So that means in the question itself they have said that okay, this is a probability distribution, so we don't need to actually verify using the rules, but there is a constant k in the function here which we have to find the value of. So we are assuming here that it is already given that this is a probability distribution. That means all the probabilities must be positive and the total must be 1. That is given. So we already know that okay, it is going to be that. So we are going to use these rules to actually calculate the value of the unknown variable constant k. Unknown constant k we are going to calculate. Okay, so the method is same. When x is equal to 4, what we are going to do, we are going to take p4. Now the function is given as 6 minus modulus x minus 7 upon k. Now modulus means that when we remove the modulus, any value which is in the modulus will stay positive. That means if I take 4 minus 7 and my answer is going to be negative 3. So when I remove the modulus, it is going to be positive 3. So 6 minus positive 3 will be just 6 minus 3, which would be 3 upon k. Let's take x is equal to 5. So that will be p5. 6 minus modulus 5 minus 7, which would be negative 2, but because it's a modulus, it is going to be just 2. So 6 minus 2 will be 4 upon k. I'm going to move on with the same thing here. 6 minus 7 into modulus, that would be 6 minus 1, which would be 5 upon k. Similarly, when I take 7, 7 minus 7 is 0. So 6 minus 0 will be 6 upon k. X is equal to 8 will be 8 minus 7, which is 1. So 6 minus 1 is 5 upon k. When I take x is equal to 9, 9 minus 7 is 2. So 6 minus 2 will be 4 upon k. And last, when x is 10, p10 will be 6 minus 10 minus 7, which is 6 minus 3 upon k, which would be 3 upon k. Now, this is already a probability distribution. So the total of all the probabilities must be 1 and all the probabilities must be positive. So let's just try to make a total of all the probability here, which are 3 upon k plus 4 upon k, similarly up to 5, 6, 5, 4, 3 upon k is equal to 1. Now because k is common in the denominator or all of these values, we will take the total of the numerator here, which is 30 upon k is equal to 1. So that would be 30 is equal to k. That means k is equal to 30. So the constant value of k here is 30. So the divisional value of all the probabilities here will be 30. We don't need to actually do anything about it. We just need to find the constant value k, which is 30, and that would be the end of this sum. Next time I will do some illustrations, explain one or two more concepts and maybe one or two sums from the exercise also. So wait for that. If you like this video, subscribe my channel, like the video, share with your friends. And if you like how I explain my sums or how I present it using the PowerPoint presentation and animations, just put your comments in the below comment box. It would be a great help for me in the future. If you have some suggestions, then that also you can comment in the box below. I will see what I can do about it. Thank you for watching my video and I will see you next time. Welcome students to Vitan Sir's Unacount Academy. That's better way to success for you. I am Vitan Vora and I teach accountancy, statistics and social science. You can contact me on my cell number 919426310184. Please give a sub to my channel and also check out my other video playlist which you can see on the screen. Thank you and I will see you in the next video.